Greetings. What are op-amps? High gain. What's an op-amp? Op-amp is a high gain differential amplifier. High gain differential amplifier. So what is an op-amp? Simply we can say it's a high gain differential amplifier. And it was invented in 1960s. Okay, so where it was used initially in analog computers. These op-amps were used to design analog computers. Analog computers. So it was used to do some mathematical functions. To do mathematical functions. So what are those functions? Like addition, subtraction, subtraction, then integration, differentiation. So all of us knows these are the mathematical functions. Differentiation. So to do these mathematical operations, this op-amp were used in 1960s in analog computers. Now we'll see what is the circuit symbol for this op-amps. The circuit symbol for op-amp is just like a triangle with two inputs, plus and minus, and one output terminal. Output terminal should come from here. Let me draw it once more. Okay, we have two inputs, that is plus and minus, and this is the output. Now this plus input is known as positive input is known as non-inverting input. Non-inverting input, and the negative input is known as inverting input. Inverting input and the non-inverting input. So now how does it work as a differential amplifier? That's what an op-amp operational amplifier. So let me draw it once more. So now we know we have two inputs. This is the output. The plus input is a minus input. So here my input is E1 and this is my input E2. And the output will be given as V out will be equal to A times the differential input. That is what is the differential input? It is E1 minus E2. This is the differential input. And this gain for an op-amp is in the range of 10 to the power 6. So it's a very high gain. And we have to provide a power supply for this. How do you provide the power supply? There has to be a negative power supply and positive, plus and minus V. How do we get such a connection? I'll just write here. How do you make such a power supply? So this is my usually it's powered with 12 volt. 12 volt. And one more power supply. This is going to be the minus 12 volt. This will provide the minus 12 volt here. And this is the ground. The ground. So ground also we have to show in the op-amp. This is there. The ground is understood. It is there, and the output will be V out will be with reference to ground. That's what we are going to make the measurement. And one more important key point you have to remember is that the op amp is a voltage sensing device. That means what? The current flowing through this current I equals zero. There is no current. That doesn't. That input current is zero. Now we'll draw the transfer curve of characteristic curve. How does the characteristic curve looks? If I draw it here, okay, I draw. Okay, this is our what we can take it as V is the V input. One second, let me take the pen. This is the V in, and this is the V out. And if we draw a curve, we will get a. This is a characteristic curve of a op amp. How do we get it? See, you will get a transfer characteristic curve like this. It's not like this. It has to be straight. That is straight. It has to be straight. If you see, this is the linear region. This straight line from here to this point to here, this is the linear region. This is the linear region. How do we write the linear region? So if we draw, this is a slope. This slope is the gain, and this gain is going to be very steep. This is the gain. This slope gives the gain, and this is going to be very high value. So what happens? And this is after the linear region. This is the linear region. After this, as the linear region, this goes to the saturation. V minus V and plus V. That means what? This will go to the power supply. Once the op amp gets saturated, it will go to the saturation region. That means the output of a op amp depends on the supply, whatever the supply we are given, applied. So this is the basic idea about the operational amplifier. Now, what are the applications of this operational amplifier? Applications. What are the applications of this? Broadly, we can categorize these applications. Amplification. Can be used for amplification. Then what else is there? Then filtering applications we can use. As a filter, we can use it. Then for switching also we can use this op amp switching. What's the next application? We have non-linear wave shaping. There will be a continuous video on this op amp series. So many videos are going to come, and you can study almost anything about op amps. So switching, then something called non-linear wave shaping. Non-linear wave shaping. Let me write it properly. It's non-linear wave shaping. And finally, as a wave generator. So different kinds of wave we can generate using this wave generator. Then finally, I want to conclude with this inverting and non-inverting terminals. Okay, see, whatever we have written, in this plus and minus, this can be reversed also. Then what happens if the input terminal, what if we are giving the signal to the non-inverting terminal? Positive is the non-inverting terminal. If we give non-inverting terminal a increasing signal, output also will increase. Similarly, if you apply a decreasing signal, output also decreases. But if you are giving increasing signal to a non-inverting terminal, we will have a output in the opposite direction. So if we give a decreasing signal here, we will have a increasing signal in the output, the opposite direction. That means the input is inverted at the output. So it's a simply we can say this operational amplifier is a differential amplifier, high gain differential amplifier. The next video we will see about what are the ideal and practical characteristics of operational amplifier. Thanks for watching.